Hello, in this video we're going to be looking at the design of an Eaves Beam using the WinZone wizard. First of all, we're going to add our Eaves Beam set. This has gone underneath the main building, which means it's already got the wind load calculated on this building, and hence the WinZone wizard icon has appeared. Going to select the normal load case and add a wind zone. And we're going to look at the first part here, the first bay, which is going to be the most onerous. So the distance to the first purlin is going to be 1 meter. Distance to the first rail going to be 1.5 because we've got rails at 1.5 meter centers in this case. We've got region length of 6 meters, beam length of 6 meters. We're starting from 0, so we hit refresh. Just take that. Actually, we'll just pull it round so it's on the right side. There we go. So our zone has appeared. You can look at the pressure on the wall, which is pressure of 0.874 negative, and then suction of 1.03. If you want to look at the roof pressures calculated, hit that on there, and it will show them again. Also shown up here. You can take snapshots of these images as well. So we're going to save that. Going to come down to our Eaves Beam design. Call it end bay. It's pulled through the roof slope from the previous work. We now set our distances to the first purlin and to the first rail. Put in a height of wall to be supported. In this case, we'll put 5 meters in just to allow that. Set your deflection criteria. Got a span of 6 meters. Number of restraints to the purlins. We'll have 1 number minor axis restraint to the purlins. That will effectively mean the Eaves Beam is spanning to the splits the span in half, so it's spanning between the tie and the support for the minor axis only. Now, when you get down here, you've got a choice of roof and wall loads. You can manually input them in as a uniform load, calculate themselves. You can use a stepped wind analysis, or you can where you input the loads manually, or you can just input the WinZone wizard. Now we're going to we're not going to check dominant openings. We'll turn that off. We are going to edit that. So we've only got 1 zone applied, so we just highlight that. Hit selected. Same again. Edit. Hit selected. You could obviously input a inner bay wind zone if you wanted to. If you had a longer span, shorter spans internally, wanted to change the Eaves Beam, but we're just going to look at 1 today. We've obviously got our wood loads, which we put in at the start under the main building that have been brought through here. Just worth checking those. So I've got 0.6 for the imposed, services load, roof cladding, wall cladding, gutter, weight of water. We've got the water calculator, so you can actually calculate the weight of water that's going to be in your applied to your Eaves Beam by putting the dimensions in. There we are. And then we've got the equivalent snowdrift load, which we aren't going to worry about today. Then we can hit calculate. So we can see the selected Eaves Beam has failed. So we hit this little cog here, and that has then selected the lightest Eaves Beam, which passes the design criteria. Recalculate that, and then save. If you want to generate a quick report just to check your output, you can do that here. And that's how you design an Eaves Beam. Thank you.